Hi, I'm Tim Berglund with Confluent. Welcome to Data Pipeline's Lesson 5, Joining Streams of Data with ksqlDB. So previously in this course, we've done some ingesting of data into Kafka. We've got ratings events from our customers telling us what they liked or didn't about our products. We appreciate their opinion, as always. In reality, this would come from the producer API, probably of some service that had a REST endpoint, and some mobile app or web front end or something would be throwing little pieces of JSON at it. But we're simulating it using the data generator connector. That's a fully managed connector in Kafka Connect in Confluent Cloud. So to find out more about who those customers are, they have opinions. We want to know who they are. We're going to pull in a mirror of the customer table from a database into Kafka using Kafka Connect. All right, we have to get that customer data into Kafka to be able to do this join in real time. So let's see how we can make this happen. Kafka topics are streams of events, as are ksqlDB streams. Streams are kind of a lightweight abstraction on top of topics. And it's appropriate, by the way, sometimes we say stream when we're talking in ksqlDB terms, because that's the appropriate abstraction. That's what it is in ksqlDB. But there's always a topic underneath it, so you should keep that in mind. Streams are unbounded, and each message gives us some information, usually tied to a key. In fact, events by default in Kafka, and certainly in ksqlDB streams, are a key and a value. Now, we can use streams to build up state, and we're going to call that state a table. This is a little tricky the first time through. So if this is your first time through this, maybe watch this twice, or we'll just take our time here. But as each event arrives on that stream as the input, we capture its value for that given key. It has a key and a value. Now the key likely would be a customer ID. Here I'm showing you names on the slide, so they're super easy to see. On the left is the stream, and I'm going to fill that stream in with some events. On the right is the table, and every time there's a new message in the stream, I'm going to update the state in the table. But when the same key appears twice in the stream, those are two perfectly appropriate events in the stream, watch what happens in the table. Just keep your eye out for that. So anyway, right now, Allison is a customer. I've heard she's a super cool lady, and she's just been moved to the bronze VIP status. Personally, I think she's being robbed. Strikes me more as platinum type of person to me. But here we have an event on the customer stream. You see on the left, that comes from the database, by the way. It's Kafka Connect is reading things from a database and producing them into this stream. And now the table that we're creating also has Allison equals bronze. Another customer is created in the source database. Kafka Connect picks it up. Maybe it's doing log-based CDC, and it writes it to our stream, our topic. And that event comes through on the customer's topic and then into the ksqlDB stream. Rick, it turns out, is a silver VIP. Look at Rick. He's awfully fancy. Silver VIP status customer. And so we have a second entry in the stream, a second event in the stream, and a second entry in the table. Why in the table? Well, we haven't seen Rick yet before. He's a new key to us, so he becomes a new entry in the table. At the moment, the table looks just like the stream. So you may be wondering, Tim, you said this was tricky. I'm confused. What are you even doing? Well, let's keep going. So, now we get another update. There's probably literally a SQL update to the source database. Kafka Connect picks it up, writes it to the topic. Well, it looks like Rick is platinum now. I don't know who he knows, but there you go. He's platinum. And that message is now in the stream because it's a new event. But notice what's happened to the table. The table hasn't gotten a new row because we already had a Rick row. It's just updated. So you can see the table tells us the current state of these keys in the stream. The stream is like a log of everything that's ever happened. The table is a snapshot of what everybody's current value is right now. So Rick became platinum, and there you go. Oh, hey, but looks like Allison is moving up in the world too. I'm encouraged to see this. We get a new event. She's silver. Total of 4 events in our stream, but still just 2 in our table because we've only ever seen 2 keys. Allison and Rick are our whole world, really. Everybody we know and do business with is just those 2 people. We're hoping for some growth later on in our simulated company, but this is what we have now. Oh, hey, speaking of growth, here's Hugh. Hugh comes along. He's gold. That record was inserted into the source database. Kafka Connect, doing its log-based CDC, we imagine, picks up that mutation and produces it into the topic that is the the customer stream that you see on the left. But now we need a new row in the table because we haven't seen that key yet. So now we have a total of 3 keys in the table. All right, now we know how to make a table. And we're talking about joins here. We kind of slipped that table in on you because we need a table to join to. What we want to do is join a stream to a table. And this joining a stream to a table is actually pretty intuitive. This is probably going to click if we talk through this animation here. But I want to make sure first that you realize we just took a topic basically and turned it into a table. And that makes all the sense in the world. Streams can become tables. Tables can become streams. What we did is we took a stream and we made it a table. And now we've got this thing where we can look up customer VIP statuses by name efficiently. So that table. And that table is represented on the top left of the animation you see here. So now below that is our inbound stream of ratings events with sort of an ID or a name of the customer and the rating itself. We don't have any information. Like we want to know what's their status. Is this somebody who's platinum? You know, should we really think about what they have to say? Or is it just a bronze person and we can disregard them? Actually, hopefully our customer service is a lot better than that. But you know, we're doing the join. So let's talk through it. So if you look at the ksql query down at the bottom of our little iMac monitor there, it's describing a join, an inner join. And if you know SQL, that is all entirely familiar with the exception of the emit changes thing. Don't worry about that for now. That's a ksqlDB detail. But as those events on the blue ratings stream arrive, we look up the customer in the customers table. And, you know, we've left platinum and customers and things in this example. We're looking at sensors and brand names, but we're able to join that event in the stream to the entity data in the table. And for those things that have matches, they change color to that green and they move on. For those things that don't have matches, you see some of them don't make it because it's an inner join. So those, if they don't find a corresponding record in the table, they don't become a part of the output stream. So it kind of acts like a database join at that point. And it's worth pointing out, just as an aside, that all this, we're talking about ksqlDB here, and all these things ksqlDB does very well and easily in SQL. They also apply to Kafka streams, which is really under the covers, the API on which ksqlDB is built. So I'm showing you this with ksqlDB very intentionally. Works very easily in Confluent Cloud, and it's kind of the standalone stream processing language. But you can do this in Kafka streams as well with K-streams and K-table objects if you're writing Java applications. That's all doable. Okay, so having seen that animation, let's go back to our users and our model that we were talking about. Here's our data. The source event is ratings information with a foreign key of user ID. So we've got an ID, right? You see that in that JSON. There's a message, needs more peanuts. Okay, thanks, 1 star. Sorry, we didn't have the kind of peanuts you wanted. But user 3, who might that be? Well, up in our customers table, user 3 is Joanna Smith. Joanna Smith is platinum, and apparently she really likes peanuts. So we're able now to join those two things with such a query into a combined record now that has the stars of her rating, her message, her email, her name, her status, all those things you can see there on that slide that are done by that join. Those two independent objects, one an event in a stream, one an entry in a table, are joined into a new object and produced to a new stream. A stream table join produces a stream. So that's it. That's joins in ksqlDB. This is a very common thing in a streaming pipeline because you've got some source of input data. There's always something you're going to want to enrich it with. Everything's a foreign key, right? You're going to need to go look something up and enrich that stream with that new lookup table that you've created as we walk through here and produce that enriched result back to a destination topic. So very important skill for you as you build your pipelines.